Hello there, I'm Sean Greasley, and welcome to our next tutorial on basic graphics within DirectX. Okay, we've now discussed what hex is, we've now discussed how to create a blank application within C++ using the DirectX functionalities. We'll now look at the differences between the blank application and drawing graphics on our form. So we'll launch this sample application. We have two triangles. Now let's see how to create these triangles and how this program works. So unlike the example from two tutorials ago, we're going to look at the differential aspects of this program and how to incorporate graphics. So the first thing we notice, we are creating a vertex buffer to hold the vertices for the rectangle. Now the way DirectX works is that, let's launch this for example. It's made up of, if you'd like, vertices, this whole shape here. What DirectX can do, it can only draw triangles, or points, or lines to join these up. When you specify points, coordinates, you specify them in a clockwise order. So when you like to map out a shape like so, it's best if you take a piece of paper, draw your square and map out where all the coordinates will be. So this would be 0, 0, then this one may be 0, 2, 2, 0, 2, 2, and that's all our coordinates for each vertice on this shape. So we need that one, that one, that one, and that one, of which we're creating two triangles. 1, 2. So that's how to actually draw shapes within DirectX. You need to draw the triangles and figure out how to make up these shapes. If we'd like to draw a 3D shape, for example, we need two triangles here, we need two more triangles for the back face, two more for the bottom, two more for the top, and two more for each of the sides, and that will give us a cube, which consists of 6, 7, 4, 12 triangles in total for a cube, whereas we have 2 for a square. Okay, let's cross this off and look at the coding on how this works. So we're creating a vertex buffer to hold all the vertices of the rectangle. As you can see, our square we just had up, it had 2 triangles in total. Each triangle had 3 vertices, so we have 6 vertices in total. So this vertex buffer will be holding an array of 6 values, because we have 6 vertices on our shape. Once we've done this, we've created the buffer, set it to null. We're creating a structure for our custom vertex type. This is kind of like a class, if you'd like, within C++. Struct, we're creating our custom vertex of properties x, y, and z, which will be the x, y, and z coordinates of each point on the triangle. Z representing the 3-dimensional coordinate, x and y your normal, if you like, coordinates, 2D. We're then creating a 32-bit value color, which will hold our hexadecimal color value for each vertice. Each vertice, as you can see on here, has its own color. See, this vertice has a red value, this one has a green, this one has a red, this one has a green, these two have a yellow. So the color value will hold the hexadecimal value for the vertice color. Sorry. We're then defining a preprocessor function. As you can see, the structure of a vertex in our vertex buffer. We're creating a direct 3D FVF custom vertex of x, y, z, and diffuse. What this does, it's applying a custom vertex using x, y, z values. As we see, we're specifying an x, y, z coordinate for each vertex, and this is the color. We're specifying a color for this. So this is what the definition function does here. As you can see, this is very much similar from our first example. This is creating our direct 3D object. This is the monitor refresh rate. There's swap effect here, back buffer format. This is our stencil, 16-bit format there. we're then creating the device and turning on the Z buffer so we can create elements behind what we're seeing. And what we're doing now is turning off the lighting as we're using our vertex colors. If we had this on, then it would specify lighting within DirectX. But because we're specifying colors for our own vertices, we're turning this off so we can have a vertice red, yellow, for example. The cleanup command then extends as we're releasing our vertex buffer. We're creating a global pointer vertex buffer, so we do need to release this, otherwise it will use valuable resources when we exit the program. A whole new function here, I will come back to that setup geometry in a second, and the setup view matrices. So what we're doing now, the render here is quite similar to before. Look, here's our device, we're clearing the back buffer, we're beginning the scene. Then the extra piece of information here, we're defining the viewpoint. With DirectX, there's something known as camera. You can think of the camera as your eyes when you're looking at your program. If you're holding a camera, say a digital camera, and you're looking through a little window pane, what you see through the window pane is like your application on your monitor, for example. So we're defining the viewpoint, which sets up the camera angles within our application. So if the device is set up, we're passing the control to us, set up the view matrices. As you can see, we're setting up the view matrix. This defines which way the camera will look at and which way is up. So the here are three coordinates. Sorry, these three lines here look at how the camera functions within your program. I think I may look a bit more detail into these in the next example, but just take into account that these three lines here modify on how the camera prospects your shape on your application. For example, this one here, these are x, y and z coordinates. It's got an x of 0, y of 0 and a z of minus 35. If we change that to 0, then the shape will appear closer towards us. Okay, I will describe that in the next tutorial, so don't worry if you don't understand this immediately. More information in the setup view matrices. We've got the Direct 3D extensions matrix as a map view. It's really spaced out, it's more clearer to read. Apologise. Matrix look at LH. You see it's setting up the camera angles here, and we're telling the device to set the transformation as this map view here. You'll understand this more in a couple more tutorials later when we'll be looking more at how to set things like this up. So we now want to set up the projection matrix. As you can see, this transforms the 2D geometry into 3D space because when it generates, we've got a 2D image, but we now need to specify this into a more three-dimensional objective, if you like. So we're creating up another class variable here, as we did up here. We had map view, now we're doing map proj. Then the extensions matrix refreshive for LH. There's the address of our variable here. We then doing the inbuilt pi function, which is built into DirectX 3D extensions. Divide it by 4. I can't remember exactly what that reference does, but these two here is our viewscape. For example, we've got an x, y and z coordinate shape. You know, x is across, y is up, and z is backwards and forwards. If we define the view outside of these two values here, then we will not see this in our application. If we look at this, our shape resides within the region minus 35. If we set this value to minus 200, we will not see this because it is outside of our view range. These two values are what you could call a view range. I'm not sure of the exact scientific name, but if you call it a view range, it gives it a meaningful definition. So if we set that to minus 200, we won't be able to see it because it's outside of our range here. But if we set this to like 300, for example, with a big view range, we will see this because it's inside our range. So these two are the range of what you can see on your application, if you like. It's like perspective. If you really look into the variables and classes used within DirectX, it's pretty self-explanatory. As you can see, they all begin with the Direct 3D extensions matrix. There's your class you're creating. That's the perspective, so obviously using your class here. Pi divided by 4. That's either circumference, I can't exactly remember. Pi divided by 4, I think that's the degrees. Obviously, I'm not good with math in all honesty, but I'll get back to you on that one in our next tutorial. That's our viewscape. We're then telling the device to set transformation as our class we've just created here. So that is how to set up the matrices. All this does is just setting up your camera angle, if you think of it like that, if you don't want to get into the specifics. So on with the render function, we've defined the viewpoint, we've got our camera set up. Render the context of the vertex buffer. So this is a new set of statements here. As you see, remember in our blank application we had an if statement. Once we begin it, we ended it because we weren't displaying anything at all. But because we're displaying a shape, we need to set up the camera, and we need to display the content of the vertex buffer. I haven't actually showed you what's in the vertex buffer because we haven't covered that function yet, so it would help if I did that now. If we scroll up, our next function within the DirectX application is our setup geometry procedure. What this does, it defines the number of vertices used in our program. It does help if you set it up like this, because we do know that every triangle has 3 vertices. Triangle, it has 3 sides, it's all 3 about it. So if you always put a multiple of 3, there's no need to calculate how many vertices your program uses. So if you say 3, then you insert the number of triangles you're using here. Because each triangle has 3 vertices, it makes much more sense. So if we put 2 times 3, we know we've got 6 vertices we're dealing with. We then need to allocate the size of the buffer. It's like similar to a printer buffer. If you send something to print out, each printer has a buffer which it stores all the documents in. So we need to allocate the size of our buffer according to the number of vertices we have, which is vertices. We've got 6 here, so the buffer size is 6 times the size of the custom vertex. This allocates a buffer size necessary to hold our shape. No unambiguous size and memory usage here. Now, as you can see, it says now get the Direct 3D to create the vertex buffer. The vertex buffer for the rectangle doesn't exist at this point, but the pointer to it does. So this is the pointer to our vertex buffer, as we explained at the top here. There's our vertex buffer device we created at the top there. So we now need to create this. Now we've allocated the size. So this is how to create our vertex buffer. Very important statement here. Then once we've done this, we need to, as you can see, fill the buffer with appropriate vertices to describe the rectangle. The rectangle will be made from 2 triangles. As you can see, we're using 2 triangles. Create a pointer to the first vertex in the buffer. Also lock it so nothing else can touch it while the values are being inserted. So we cannot just generally draw our shape in any particular way or form. We need to specify the first vertex in the buffer, as it says in our comment here, lock it, then draw our shapes. We cannot draw our shapes while our application is continuously refreshing, because, like, remember in our monitor example, for example, when it was refreshing 60 times a second, and the computer can obviously render 4 times faster than this. So while we're creating our shapes, we don't want DirectX to mess around with our application. We want control while we do our own thing. So what this does is creating the pointer p vertices here of the type custom vertex. This is a bit of a mouthful, but what it does, it points, like it says, to the first vertex in the buffer, then locks it. So it's clicking up kind of like a void pointer, locking it, and returning either a fail or a success value. So once we've got the control, we can then fill the vertex buffers with the data. Remember, we created an array here of 6 values, which will be 0 to 5, as you can see there, and then we input the coordinates of our vertices. Like we said before, if we run this application, I've used values from 0 to 10 instead of 0 to 2. So the first vertex here has a coordinate value of 0, 0, 0, because x is 0, y is 0, and z is 0. It's not out or it's not in. It's a two-dimensional shape. If you're playing around with two-dimensional shapes, you'll notice that all the z coordinates will be 0 because you're not either forwards or backwards. It's just the x and y coordinates. Our next vertex, I think, is this one. Yes. As you can see, the x is 0. We're still here. Y is 10, so we've gone up 10 units, and z is still 0. Then we're colouring this vertex yellow, which is full red, full green, and no blue, which is the hexadecimal value for yellow. A third vertex is x value 10, y is 0, and z is 0. And that draws our first triangle. As you can see, triangle 1, 3 vertices, 3 sides, 3 array values. Second triangle, 3 array values, 3 sides, 3 vertices. Each has its own unique colour. If you do all the vertices as the same colour, then the shape will be a solid colour. For example, so play around with many functionalities in this. So that is how to render your shapes. We then want to unlock the vertex buffer, so direct 3D extensions and whatever can have its control back to do what it likes with our shapes and such. And once we've done this, I'll just show you the final attribute here, which has been added to WinMain. We described in our last example, when Direct 3D is set up successfully, we're adding a new if statement here. So when Direct 3D is set up successfully, we want to make sure that our scene has been set up successfully. So if succeed is set up geometry, which is our, remember, camera procedure up above. So if that succeeded, then begin the message looping function. So that is how to draw graphics. The only differences are we're creating a vertex buffer, we're creating a structure of a custom vertex which holds values, coordinates of x, y, z, 32-bit type specifier of color to hold our hex values. We're defining a custom vertex to hold x, y, z values and a color. That is all pretty much the same. We're turning off the lighting. We have to release our vertex buffer. We've got a whole new procedure which sets up the geometry. This procedure, remember, doesn't actually draw anything. Render does that. It just sets up the backbone, if you'd like. This sets up our camera. This draws our new objects. As you can see, I did forget to go through this piece here. Render context of the vertex buffer. This actually draws our vertex buffer, you know, 6 value array we had. And what you do, you set your stream source here. There's another function which sets the FVF of the custom vertex. And the last line I'd like to pay particular attention to is the draw primitive. What this does, it's quite unique in the way that it works. Our first attribute is the Direct 3D presentation. I'm not sure what the T is, but it's not actually that relevant anyway. Then the order or style, if you'd like, in which you're drawing your application. It'll become much clearer in this example I'm about to show you. So what we're doing, we're drawing a triangle list of 2 triangles. So if we change this to triangle strip, for example, that's another value. Ooh. Triangle strip. Okay. Linking, no warnings. As you can see, we've got 1 triangle. What this piece here does, it's a style in which your array is presented on the screen. what we had before was triangle list, because we're specifying values for coordinates to make up a list of triangles, and we want to display 2 triangles. If we change that to 1, then even though we have our triangle list, it should only display 1 triangle, as you can see. So this function here determines how many triangles you're displaying in your program. So do remember, if you've gone on to modify this program to create a cube which holds, how many did I say, 2, 4, 6, 8, 10, 12, 14 triangles, you need to change that to 14 triangles. So at the moment it's only rendered 2. But this option here, there's many different options. We've got, as I've described, triangle list, triangle strip. There's one called triangle fan, which is useful within creating circles. Triangle fan is a shape which in which all vertices share a common center. So the first vertex is the common center, so I suspect this will not draw properly at all. Yes, we've got 1 triangle again. Well, that's useful mostly for creating solid circles. We then have a point list. And we press that one there. And what this does, it displays the vertices as a series of points. I'm not sure if you can see exactly, but we've got a white dot here, a red dot there, there's a dot here. Take my word for it. What it does, it plots a point for all your vertices. It's like a dot graph, if you'd like, something like that. So we've got a point list. We then have something called a line list. Let's execute this one here, and this creates a line list for each of our vertices. We've then got remember it's only going to display 2 of whatever you put in here. I think the next one is a line strip off the top of my head. I think that's about all the ones I can take off the top of my head. Yeah, as you can see. So some techniques are useful for different things. See, if we'd like a triangle that hasn't been filled in, then this may be the best option. As we've only got 2 here, it's only going to draw 2 lines. Let's try 6. So, different functions can be used for different things, if you'd like. As you can see, look, we've got 6 lines drawn here. So, do experiment with different functions. If you can't remember them, we have the line strip, line list, point list, triangle strip, and triangle fan. And do remember to allocate your number of whatever parameter you have in here. So once you've ended your scene, it's rendered, and that is really how to draw graphics within DirectX. I hope this tutorial has more expanded your mind on what you can do with DirectX. I think in the next tutorial we're going to discuss the camera angles, and how you can adjust camera angles to position your eyesight around the application. So, I've been Sean Grizzly. Thank you for listening to another exciting tutorial on DirectX 9. I hope you enjoyed it, and good night.